So a very important thing that you should know is called a S curve or sigmoidal curve. So this is typically the curve from you can see from 0% and it can goes nearly 100%. Sometimes if it goes beyond 100%, then which means your project is incurring cost overrun, right? So which means that you are exceeding the budget or your project management was not good, so that your control mechanism was pretty weak, so that the budget was not met, but instead it goes for the higher cost or something like that, right? So that's basically the sigmoidal curve or S curve, right? So we'll be discussing this in much detail, right? But if you talk about percentage of cost in design stage is pretty much limited when compared to the construction stage, but the level of the influence, if you could able to give 100% accurate proposal or budget, then finally your construction cost will be as met equivalent to a budgeted cost. Otherwise, it will be a deviation, right? So that's why the influence is pretty high during design stage, like the budgeting and all, right? So if you have a good design and if it results in a good overall specific construction process, then it is pretty much profitable to the company. But if you have not done something earlier or you are not anticipated that, but that incur in the later period of time, then it will be a disaster. It will be a cost overrun generally, right? And this is true for time as well. Even for scheduling, if we don't pay attention to all the type of activities and its influence or its duration, then it will be detrimental in the later part of the or during the course of the construction. Say the water table were not considered higher, the groundwater table were not considered initially, and water table for that particular constructible area is pretty high, then you have to provide dewatering in the initial stage itself, like, but you forget that, and when during construction you find that water percolates into the pit, then dewatering will be an additional burden for the contractor and it incurs additional cost. So all cost, time and quality are interrelated, and this is pretty much called as iron triangle or a project triangle, right? So this is typically the cost consideration, and this curve, S curve, is called sigmoidal curve or sigmoid curve, right? And very much important is cumulative construction task. Earlier, we used to do traditional cost management system or traditional costing system, when which we record all the observations in the ledger or a notebook, and we try to reconcile that or try to close the balances as in when the day closes or even a week's closes, something like that, right? So that's a traditional cost management system. But now people talk about activity based costing, so that has huge importance. Instead of a per day or per week timely cost legend, we can look into the activity based, like when the activity gets over, that particular cost should be summed up so that it can be raised for raised in the bill for the client, right? Something like that, right? So that's typically an activity based costing. So once we generate activity based costing, we also have a control over which activity got completed and which activity are pending and which activity takes much longer time. So that's kind of a very much an additional mechanism over the traditional ledger based costing systems or something like that, right? And this is typically applicable for labors as well. In fact, the daily wages or the unorganized labors, instead of cost ledger system, you can have an activity base, so which means that we can see which labor gets paid or which labor turns up daily and something like that. So that's very much important in terms of activity based costing. And there are some estimating packages, like cost estimating packages. Two things I like the most. One is the general Excel spreadsheet, in which you can make up the cost, tabulations, and you can calculate the costing, and it can also take a look at the forecasting if you are pretty familiar with forecasting techniques and all, right? Right, that's simply the best tool if you use Microsoft Excel spreadsheet or any Excel spreadsheet. Like LibreOffice is open source, like it also have a spreadsheet program, so you can use LibreOffice or something like that, right? And database softwares, like pretty much, and nowadays people talk about SQL, SQL databases and all, right? um, to be very honest, like there are a lot of job opportunities for allied engineers in database management system, when which like many construction company nowadays move to electronic database. So all their design standards and design procedures gets stored in cloud or even in a remote software, so that nowadays like people can look into multifarious projects at a single point of time, or a single point is or in a single location, right? So this database can be a very huge influence. That is why in Revit itself you have a cloud integration nowadays, like you can store your Revit model in the cloud rather than your desktop, or you can sending via email in the older period of time, right? So that's pretty much an important thing, right? I'll give you a brief overview of building information modeling and using Autodesk Revit, probably in module number 8 or something. I also invite a guest speaker who's famous in this particular field to deliver the actual current strategy or something like that, right? So this is typically and very important, right? Right. A database software, one such thing I feel is the Autodesk Quantity Takeoff. In fact, I've used this for more than 5 years, and this is one of the best quantity takeoff before building information modeling, right? So once the BIM has comes in, nowadays nobody goes for a separate quantity takeoff. They do it with the BIM packages itself, right? So, but this is nevertheless a great tool. You can make a beautiful documentation and something like that. So you can take a look at this whenever you're free. So now you can even integrate this with the BIM packages as well for additional, takeoff facilities or something like that. Right. And the next we'll move on to a very important concept today is the safety management, right? Safety in construction. This is one of the key feature. In fact, safety is a predominant factor that should not be overlooked or compromised in construction, right? So people generally look for choice of, equipments, choice of labors or skilled or semi-skilled labors, but safety in the sense cannot be compromised. There won't be anybody who want to risk their life and risk their company's reputation because of compromising safety or cost savings from unsafer practice, something like that. So the safety is a predominantly a very important factor. Whenever you talk about safety, first thing is non-safer environment or hazardous environment, or pretty much in a very menial term, it's accidents, right? So that is the first and foremost important thing. But there are a lot of theories on accident, like you can take a look at that whenever you're free. One such thing is the carelessness of the employee, or sometimes even the fatigue of the employee. So employee works in a factory line production. He is in charge for a particular division, and if sometimes the divisions people they could not able to achieve as budgeted or as planned, then it will be the stress. It will be a stress to the the team leader or something, right? That can be a fatigue accident also. He might uh, you know uh, collapse, or he might feel uncomfortable or something like that, right? That is kind of a psychological accident, but physical accidents are the one that is detrimental or something like that, right? And one such problems in our country is the accommodation of safety procedure, or in fact the safety markings or something like that is need to be done still in major companies or something like that, right? So what is an accident? Is any occurrence that interferes with the orderly progress of the activity. Say they could be a deviation, like instead of uh, producing 500 units, you even can't able to make 200 units, then that's gonna be unsafer, because the time based and effort based, and also the capacity of the machine not used or something like that. Or sometimes if an machine has a capability of producing only 500 units, and your manager requires 550 units, then 50 units is the additional capacity than the machine, then it'll be in a disaster if something goes wrong, right? So those are things are safeties. And there should be a proper documentation, proper evidence for safety claims and all, right? So we'll talk about that a little later. There are two losses due to accident. One is a direct loss. It is the medical or physical loss, or in terms of monetary loss. Indirect loss is the time lost, or the machine gets you know the efficiency of the machine gets reduced, or even the injury causes to a skilled person, or the best person or best employee in the company. So that's an indirect loss, right? So direct losses and indirect losses are huge detrimental or upset to the productivity of a company. Not only to that, it's also personal level loss to the people who got injured. And there are plenty of causes for accident. One is due to the dangerous machine, unsafe working conditions, moving objects, and personal factors like substance abuse, or even the psychological factor I just mentioned a couple of minutes earlier. And then unsafe acts. Sometimes you talk about the boilers. Most of the boilers in our country uh, fails, and then when they investigate that, then they see the moisture or the temperature were not controlled in that particular factory. So it will be a secondary effect, but then they may not think that that could be detrimental to the boiler or the burst of the boiler or something like that. And then human causes like negligence and other factors. Then electrical causes like if these earth, if the electrical lines are not earthed properly, then can cause failure. And exposed to harmful substances like benzene. People talk about benzene can create cancer. So people working in benzene production, a chemical factory units, they are subjected to cancer. And in fact, this is same to nuclear power plants. That's why the people live near nuclear power plants are they exposed to nuclear radiation indirectly, and then they get cancer, something like that. So that's harmful substances, something. Then discover accident causes is the first and foremost thing. So first, if there's any unsafe environment, we generally look into finding out. That's very important than to provide solution. Once you find out, then next step is providing solution. So we have to propose some remedial measures or something like that, right? Then that's it. Controlling environment costs and other related stuffs also pretty much important, right? So the famous Bhopal tragedy, the methyl isocyanate uh, exposure, and it cost a huge lives of people, right? So they could have done that. If you could see the documentary of that, there's only one valve or one disc in a valve got failed, and even the project manager or people who have reported that it would have cost only 500 rupees or less than that during that part of time. So if they would have done that, and the entire accidents would have prevented. So sometimes negligence can be a detrimental not only to the company but also to the society and the people living in that. And something like behavioristic costs, like this is a very important thing. So other things like environment and something like that we can control or prevent, but we cannot eradicate that. But behavior can be altered, like we take right people for the right job can be a good solution than putting an unskilled or cost cutting in the human resource might be a detrimental later on, right? So we provide a perfect job analysis, then job training and supervision, and also we give physical training and examination. And then we'll check their disciplines and how they work, or it can be even their degrees, safety engineers, or a specialized agents where they have a basic engineering degree plus the safety certifications from the reputed training institute, safety training institutes or something like that. Right. You might visit a site and you can see, I mean, bigger project where you can see the color of helmets determines the job nature. The yellow is generally given for laborers, and white is for the engineers or architects or planning engineers and so on. Blue is generally given for safety. And in some cases, blue is given for piping engineers, whereas green is given for safety. But other than yellow and white, So safety engineers will be given a separate helmet or separate, it's a separate entity in the construction activities. Right? And the proper placement of workers, that's very important. Not only scheduling it, how you poise them, how you hoist them, and how you you know um, manage them, right? So human resource, that's also very important in the project management. Next, we'll talk about supplementary activities. Like sometimes we can give them warning signs. We can post them. We can paste safety warnings. Say, for example, 240-volt. Electric lines passing through, something like that. No, so that's in Building and Other Construction Workers Act. We have seen that like it should be in all the languages that majority of the people are working in. Say, for example, if you only have in English, then people may not. Uh, all the people do not have much, knowledge about English, or they don't have skills in understanding English, then it'll be a detrimental to them. Or if it is only in Hindi, and some people from other places or other countries may not know, so it will be detrimental. So it will be something like universal language, then the national language, and then the regional languages, or specifically some signs. Instead of text, you can provide some signs, signage boards or something like that. That will be even better because it can be understood by anybody. When you put P and you strike off, then everybody understands it's a no parking, right? So that's simple as that, instead of writing no parking or something like that. And the essential safety programs, this is very important. Not only the job analysis and job training, but also safety programs. Even during the course of construction work, we'll be inviting professionals to give training to the people, or to enhance their understanding about a particular construction task and its unsafer environment, right? So once they are given training on which are the things on unsafer practice, then they avoid that, instead of giving them just pamphlets and pamphlets of safety practices or policies, right? So safety programs are very important. In fact, there are something called management safety programs and personal safety programs and so on, right? Management safety programs is for the not the subordinates, for the leaders, like the project managers or something, like how to manage thing or something like that, even though they have experience. But it'll be nice if they are given an additional training to keep in the pace with the current technology, something like that. And so was like subordinates, the workers were given the personal safety programs, in which different divisions are categorized, like the people involved in drilling work, excavation work, and something like that, right? So they were given separately, or some portion of it, like people looks into the substructure work, and people look into the superstructure work, or people only look into the finishing work or something like that. They have given the proper training program. And people who have done their job perfectly can be given a memento reward or something like that, to motivate them, and also to make others to understand that the company appreciates the safer practices or something. And this all the things of safety programs. That's why if you join any company as a fresher, they'll be given 6 months training or 3 months training, depending upon the company's policy. And safety precautions are generally practiced, and it should not be overlooked or compromised, right? And then some of the specific precautions, like crane, how do you operate a crane or something like that, like never operate near power lines and something like that. So these are some examples I gave regarding the crane operators or something like that. So this is called specific precautions, and this need not be a point of discussion for people who do transportation or something like that, right? I mean, transportation of a debris from a site to the landfill or something. So this is specifically to that crane operators or something like that. And air compressors, it should be securely anchored to the foundation and so on, right? So these are some of the specific precautions regarding a particular activity or a construction process. Then very important thing, housekeeping or keeping, we call this in terms of, maintaining the necessary condition, working condition. So that's what I just put it in under the term called housekeeping. But this should not be taken like only the cleaning stuff, but also to fill any patches or potholes or something like that. Or these are the people who generally checks daily. So when a crane gets collapsed, the first question they're gonna find it is like who has maintaining this particular facility, and then they look into step by step like crane operators, and then the loads and other calibration of the cranes and something like that. Right, so that's very important. So first, these people are the root level employees, in which their job is to create a tidy workplace. Then passages has to be cleaned or something like that. Like I don't know how many of you experienced the cold regions. Like if you go to cold and cloudy regions, like the snow generally gets blocked, or it blocks the passage or the pathway, generally the roads, right? So they have scrapers or screeders or some equipments to clear off the they don't do it every day. They will be look into the time in which the traffic is allowed, and then they'll be looking into when the heavy snowfall, and then that particular point of time menial snowfall, they don't comes into picture or something like that, right? So that's pretty much in housekeeping, but it's very important task, right? And electricians look into the loose holes, or loose wires, or like hanging wires or dangling wires. So it has to be anchored in earth or even insulated properly, so that there isn't much leakage of the electricity. So that's some of the important housekeeping thing. Then safety through legislation. This is very important. Unfortunately, we don't have predominant safety for construction industry alone. Like we don't have any agencies only look into construction agencies. I mean construction projects. We will be looking into guidelines from various legal acts like the Factories Act 1948, then Indian Explosive Acts in case you use detonators or something like to explode or demolish a building, and then Mines Act and for drilling and tunneling and something like that, and Indian Boilers Act, this is also very important, and then Indian Electricity Act and Petroleum Act and so on. So these are the some of the safety legal provisions that we generally look for construction project as well. But in America, they have a well established act or rules or regulations called OSHA. It is called Occupational Safety and Health Administration, right? So this was there even in 1970s. It was created by Richard Nixon, the former president of United States, and then they have combinedly developed this with the United States Congress, and its nature is to provide safer work environment, and also it looks into the healthy work of the healthier work nature or work condition of the personnel, so the workers, right? So the value of life, where the construction workers where cannot be compromised, right? So they have this particular act. And some of the guidelines, like they are there are actually so many different things, the OSHA's guidelines, right? So I've just named a few. One is like fall prevention. So this is very important. Like the fall preventions are viewed very seriously, so they don't have to climb or particular thing without the safety provisions, right? Something like that. So as simple as that. And then trench cave in, like if they have a tunnel or something, like the surface of the cave in is bulging inside and collapsing the tunnel or something like that, and put guards on dangerous machines and so on. Like that's very important. Dangerous hazardous machines will be given a proper care. All these things where there are standards to do this particular task, and OSHA has the separate guidelines. It is called OSHA's Construction General Industry, Maritime and Agriculture Standards, that protects the workers from this kind of a serious hazardous work conditions. Right. So this is regarding the safety. I gave you a quick overview of water safety and accidents and some of the safety procedures and specific precautions. Then we talked about safety programs, and they finally see safety legislation. We'll take a look at the sustainability aspects. In fact, we have done some projects on sustainability of many construction projects. probably using building information modeling. Let me show you theoretical thing that we have done earlier. Practical thing I cannot share because of its confidentiality of nature, right? So some of the theoretical model or the concepts that we used for the regular consultancy, I'll explain you in this particular thing. First, we'll talk about energy efficiency. This is a very important term, right? Normally, design, construction, contract, and ECC, and people will think of that's it, right? So, but even in construction, we need to look into energy efficiency, right? So now people even look into the energy efficiency even in a design stage while taking a design, say for example, industry building, a truss member building. So there are different varieties of truss like N truss, P truss, and K truss, Warren truss, and so on. Right. So there are different profile configuration. Generally, people do is like they take a particular truss that can hold maximum load uh, for the given span or something like that. But now people look into the material aspects like, oh, if that's the case, then what's the material used and per or they call strength to weight ratio, something like that, right? All those things they take a look into consideration, and then they also look into the economics aspect, like it is costlier or something like that, right? So those things, everything they take consider. Say for example, if they could able to save at least a 2 ton of steel used in the entire project, then that will be a highly safer or a sustainable construction, something like that, right? This all the different things, like it starts from sitting to design, then construction. So it's almost making environmental responsible and resource efficient throughout the building life cycle of a building, right? And there's always a misconception about energy efficient buildings and practice in our country. They think that it is pretty expensive, or they think that why we need to do when we have a safer building or something like that. So there's always a misconception, but sustainability is also pretty much equally important. This looks into the longer period of time, like the longest longevity of the building will be high rather than if you provide even a safer during a shorter period of time. This building information modeling, in fact, I've just explained you this BIM in the previous lectures. So first and foremost important thing is, if you're very familiar with AutoCAD, you probably know what is a block. Block is the temporary system that you can designate or develop. Say this is a panel, say 900 by to 3000 millimeters panel, and this is just a wireframe model in the AutoCAD. So this is a 3D CAD in fact, right? But it's a 2D wireframe that I've shown you. And then once you take that AutoCAD model as a reference, then you can talk about pretty much and very important thing. You can add materials to it, or you can scale down the stuff to the required dimension, keeping it one and have a multiple copy of that in a different dimension. Or you can even change the material, or when you change the material, it's not only gonna change the parameters, but it also changes the cost involved, then energy efficient involved. There's something called R value that we will discuss during module number 4. R value for it's generally calculated for energy efficiency. So if you could change a material and if you could increase the R value, then it's the best for your building, right? So, but when you increase an R value, the cost also should be increased, but sometimes you can optimize the cost as well, right? So those things are generally done for 3D CAD and 3D BIM. And then people looks into whenever people talk about energy efficiency, they not only look into the wind patterns, they not only look into the temperature effects, not only look into the lighting, but also people sometimes look into acoustics. So those also energy efficient. So this is a typical example of a temperature. You can see the vortex and you can see the intensity of temperature is pretty high and pretty cool here near the windows and pretty high across this particular thing. So this is a workplace, or you can see a computer and a table, and this is an office, and you can see how people plan that, like so 27 degrees Celsius is pretty reddish, and whereas you can see the lesser temperatures are given these colors. So this is typically the temperature gradient. And before we get into the energy efficiency, let's take a look at some of the key features of the energy efficiency or something like that. So you should know this. India is divided into 6 climatic zones. One is called cold and cloudy. Example is Shimla. And next is cold and sunny. Example is Leh. And composite is a combination of cold and cloudy and cold and sunny. So partly it will be cloudy for a particular season, and it will be sunny, and it also exposed to sunny. Sunny in the sense is not very uh, hot as in case of Chennai, but it's kind of a part, it receives part sunlight. Example is Punjab. And hot and dry is Jaipur. It's kind of a desert region. And dry air, if we dry air, Chennai is a humid, but even then it's hot, it's humid. But Chennai is generally not hot, it comes under warm and humid, right? And moderate is Bengaluru or Bangalore in older case. They experience very cool temperature during winters and moderate temperature during summer. It will not be very hot as in case of a Chennai. Warm and humid is example is Chennai, the coastal regions of our country, down south or the across the Bay of Bengal side. So this is typically the energy density of India. So you can even see, I think I don't have the legend, but you can see this is cold and cloudy, and this is warm and humid, and these are moderate regions or something like that. Yeah, all right. So we'll move on to the other thing. So this is something in Revit 2012. It's a very old Revit. In fact, this is where we have done most of our work. Floor plan of two-story building, right? So we have developed, and this is the elevation, right? So there's a reason that we kept this particular thing. I'll tell you why exactly we kept that. This is the 3D view of our building, and it's a two-story. And this is pretty much a standard building. We wanted to use it for all the 6 climatic zones. So what we have done is in Shimla, in Punjab, and then this is in Rajasthan, Jaipur, I guess so, and this is in Bangalore and in Chennai, right? So we wanted to keep that in different climatic zones. So the first is cold and cloudy. An example, you can see, take a look at this picture. And this is hill slopes, and I'll just show you. And then I've put it under cold and cloudy region, and its latitude. And then this is the temperature that you can see. See, it's pretty cold in even inside the building, and it is not very hot. It's warmer. It is not, you can not say it's a hot, it's just the warmer, and the green is intermediate between very cold and warmer. So it's something like you can see this particular thing, right? So this is how it is, you know, the cold and cloudy regions and something like that, right? And we have tried to incorporate the additional components like providing heaters or something. Then this particular thing comes in, like this blue region gets converted into green or something, like when you provide heaters or something like that, then you can enhance the thermal comfort or something like that. And you can even see the wind properties, and it's fairly the same, right? So even if provide something like without that something like that, and this is something. So this is the entire floor plan gets converted into the south side and eastern side and something like that. And then we talked about the it's a cold region, and we provide this kind of openings can be cut down to curtail it to the the glass doors or something like that. Then you can probably explain. That's the recommendation if you provide this in the cold and cloudy region. Then cold and sunny region, we experience sunlight. you can see even though it's cold, but you experience sunlight. And this factor, that's why in sun path diagram you have a sun shades. In cold and cloudy region you don't have any, the sun is there but the rays of it is not predominantly there. So this is, and then cold and sunny you can see the temperature is kind of pretty intense when compared to the other. And we also talk about the other aspects of the warm temperatures being exhibited inside also because of the openings. And this is the diurnal temperature, which is the sun, because of the sun shades and something. And the recommendation is thermal insulations, and the original window can be sealed off with thermal insulations so that it absorbs heat during day and exhibits or releases heat during night. So that'll be creating a warmer environment during night where you require some temperature or something. And the next is a composite climate. So it will be a combination of one and two, cold and sunny and cold and cloudy. This we can see the sun path diagram, and the rays is pretty heavier. And you can see there's a differential pattern when compared to all other things. So it's having a 50% of cold and 50% of sun. You can see during the openings, they have a multifarious influence. Like it gets going. The temperature is probably very high, warmer near the windows, and it comes inside. It'll be pretty deeper. And this is the diurnal temperature, when which the heat gets enhanced pretty much. And the proposal or the recommendation we can use this, I can provide thermal blankets. So in order to accumulate, in order to take up much heating during day, thermal blankets are used. So that will be a good remedial measure. And hot and dry is like the regions in Rajasthan or something like that, right? So they experience hot and dry. So the temperature is even more extreme. So it's only hot. You can see even though it's kind of a called as cool, but it's not cool. It is just like a warm air, but not as compared to the surface thing, right? Something like that. And air conditioners, in fact it's not air conditioners because it does not have moisture, so we generally recommend air coolers than air conditioners here. So then moderate regions, all Bangalore regions, you have a beautiful sun path diagram where existence or the human survival is very good. So this is a typical thing. So this is an example of a Bangalore thing. And fenestration and plantation is the recommendation. We'll plant good vegetation nearby. That will be a good recommendation for Bangalore sites. Something like that. Then warm and humid is regions in Chennai, like coastal regions. And for that, we be looking into, you can see it's kind of moderate. The reason it is not cool because the moisture, we call that as humidity, where the movement of air contains moisture, so it makes up cool, but not very cool. That's why it is pretty much like this. And then you can see the air movements and something that is temperature or diurnal temperature. It's pretty that's why you feel suffocation in Chennai weather or something like that. And there's something called fenestration or opening. We call that as in technical called evaporative downdraft cooling, right? So that's a technical term. So we will be generally have this. That's why if you've seen old buildings in Chennai, they have chimneys at the top of building, and which not only takes up heat from the kitchen, but also the air gets circulated, something like that. So the cool air are heavy, so they tend to move along the gravity. They penetrate into the slit, and then hot air are pretty